Look down at your hand for a second. Maybe there's a ring on it, or a watch, or nothing at all. But somewhere in your life there is gold, in a wedding band, a tooth, a phone, a coin. We build crowns out of it. We fight wars over it. We bury kings inside it. Here's the strange part nobody tells you. The gold you own is older than the ground you're standing on. I don't mean it's an antique. I mean the actual atoms, the tiny specks that make up that metal, are billions of years old. They existed before the sun. They existed before the earth. Every single gold atom on this entire planet was made somewhere out there, in the dark, in a place so violent it would vaporize you instantly. So how did it get onto your finger? Let's follow a home. To find where gold comes from, you have to understand where all atoms come from. And the answer is stars. A star is basically a giant ball of hydrogen, the simplest, lightest thing in the universe. Under crushing gravity, deep in its core, hydrogen atoms get smashed together so hard they fuse into helium, and that fusion is what makes stars shine. Your sun is doing it right now. But stars are like cosmic factories that keep upgrading their product. Once a big star runs low on hydrogen, it starts fusing helium into carbon, then carbon into oxygen, oxygen into neon, all the way up. Each step builds a heavier element, layered inside the star like an onion. Nitrogen in your DNA, calcium in your bones, the oxygen you're breathing, all of it was cooked inside a star like this. You'd think this could go on forever, building heavier and heavier elements until you reach gold. But there's a wall. The factory hits one element and completely jams. Iron. Fusing atoms up to iron releases energy, which is great. It keeps the star alive. But iron is a dead end. To fuse iron into anything heavier, you have to put energy in instead of getting it out. Think of it like a business that made money on every product until one item costs more to make than it sells for. The moment a star's core turns to iron, its energy income stops. Fusion is what held the star up against its own crushing gravity, and now that support is gone. So the star is doomed. And gold, element 79, is way past iron. A normal star simply cannot make it. So if the ordinary furnace of a star can't forge gold, you need something far more extreme. You need an event so powerful that it can shove protons and neutrons together against their will, past that iron wall, all the way up to 79. The universe has a few ways to do this, and every one of them is a catastrophe. The first one people discovered is the death of a giant star. When a truly massive star finally runs out of fuel, its core collapses in less than a second. Outer layers rush inward, slam into the dense core, and rebound in an explosion so bright it can briefly outshine an entire galaxy of billions of stars. This is a supernova. In that unimaginable blast of energy, elements get forged that iron could never reach. For decades, scientists were sure this was where gold came from. It's a beautiful idea, a dying giant in its final scream, scattering precious metals across space. And supernovae really do make plenty of elements. But when scientists ran the numbers carefully, something didn't add up. Supernovae just don't seem to produce enough gold to explain all the gold we actually see in the universe. There had to be another source, something even stranger, even more violent. To find it, we have to talk about the strangest objects in existence, neutron stars. When some giant stars collapse, they don't fully explode away. They leave behind a core so compressed that atoms themselves get crushed and electrons and protons are jammed together into pure neutrons. The result is a city-sized ball heavier than our sun. It is the densest thing in the universe short of a black hole. How dense is a neutron star? Take a single teaspoon of this stuff. Just a teaspoon, the amount you'd stir into your coffee. That teaspoon would weigh about 1 billion tons. That's heavier than every human on Earth combined, packed into a space smaller than a sugar cube. Gravity here is so intense that a marshmallow dropped onto the surface would hit with the force of a nuclear bomb. Now, imagine not one of these monsters, but two, locked in orbit around each other. Two neutron stars, circling closer and closer over millions of years, whipping around faster and faster as they lose energy. They spiral inward like water going down a drain, until finally, in their last moments, they're orbiting hundreds of times every second. And then they touch. And the universe does something spectacular. When two neutron stars collide, it's called a kilonova, and it is one of the most extreme events physics knows. The collision is so violent, it warps the fabric of space itself, sending ripples called gravitational waves rolling out across the cosmos. And in the blazing wreckage, in that dense soup of free neutrons, heavy elements are finally forged in enormous quantities. Elements like platinum, uranium, and yes, gold. And this isn't just a theory anymore. In August 2017, observatories on Earth felt a tremor in space, gravitational waves from a collision 130 million light-years away. Seconds later, telescopes swung around and caught the light from that very same event. For the first time in history, humans watched two neutron stars collide and saw heavy elements being born in real time. And the amount of gold made in a single one of these collisions is staggering. Scientists estimate 1 kilonova can forge many times the mass of our entire planet in gold alone. Picture that. A cloud of pure, precious metal, several Earths' worth, blasted out into space in an instant. That one event you're looking at seeded a whole region of the galaxy with treasure. But here's what I love about this. That gold doesn't go anywhere fast. It drifts. After the explosion, the cloud of newborn gold atoms spreads out into the vast emptiness between the stars, mixing with dust and gas. And there it floats, cold and dark and silent, for millions, maybe billions of years. Just waiting. A treasure with no owner, adrift in the void. Then, roughly 4.5 billion years ago, one of these clouds got a nudge. Maybe a nearby supernova shock wave pushed it. The cloud began to collapse under its own gravity, spinning, flattening into a disk. At the center, gas piled up until it ignited into a brand new star, our sun. And swirling around it, all that leftover material, including the gold, started clumping together. The clumps grew into rocks, the rocks into boulders, the boulders into worlds. One of those worlds became the Earth. So the gold that had been drifting through space for eons finally had a home. It got mixed into the molten rock of our young planet. And you'd think that's the end of the story, that the gold just settled into the ground, ready to be dug up. But no, something got in the way. The early Earth was a ball of molten rock and metal. And when everything is liquid, heavy stuff sinks. Gold is extremely heavy, and it loves to bond with iron. So as our planet melted and sorted itself out, almost all of the original gold sank down, following the iron, all the way to the core. It's still there today, thousands of kilometers below your feet, forever out of reach. So here's a real puzzle that bothered geologists for years. If all the gold sank to the core, why is there any gold in the crust at all? Why can we mine it near the surface, when it should all be buried thousands of kilometers down? The gold in the Earth's crust is thousands of times more abundant than it has any right to be. Something must have delivered a fresh batch later, after the core had already formed. And this is the twist that ties everything together. After the Earth's core had already formed and sealed away the original gold, the young planet went through a period of brutal bombardment. For hundreds of millions of years, asteroids, some the size of mountains, some the size of countries, rained down onto the surface. And many of those asteroids were carrying gold of their own, forged in those same ancient cosmic explosions. These impacts hit after the core had closed for business. So the gold they delivered had nowhere to sink. It stayed near the surface, salted into the crust, spread across the young Earth like seasoning. And that thin veneer of asteroid gold, sitting in the top layers of the planet, is the only gold humans have ever been able to reach. Every gold rush, every mine, every coin comes from that late delivery. So sit with this for a moment. The gold in your ring was born in the collision of two dead stars, drifted through space for billions of years, was baked into a rock, hurled across the solar system, and slammed into the Earth as a meteorite roughly 4 billion years ago. Then it waited in the ground until a human dug it up, melted it, and slid it onto a finger. That's the journey. Now, why did humans decide this particular metal was worth killing for? It comes down to chemistry. Gold almost never reacts with anything. It doesn't rust, it doesn't tarnish, it doesn't corrode. A gold coin pulled from a 2,000-year-old shipwreck comes up gleaming like the day it was made. It's soft enough to shape into anything, yet lasts basically forever. And it has that warm, unmistakable shine. That's why almost every civilization, completely independently, landed on the same conclusion. The Egyptians, the Incas, the Chinese, the Romans, none of them talking to each other, all decided gold was the most precious substance on Earth. It became money because it was rare, durable, and impossible to fake. Wars were fought for it. Empires rose and fell chasing it. People crossed oceans and died in deserts, all for the stardust. And yet, for all that obsession, gold is genuinely, physically rare. Here's a fact that always stops me. If you gathered up every single gram of gold ever mined in all of human history, all the jewelry, all the coins, all the bars in every vault on Earth, and melted it into one giant cube, it would only be about 22 meters on each side. It would fit in just 3 or 4 Olympic swimming pools. That's it. Every ounce of gold humanity has ever touched, from Cleopatra's jewelry to the ring on your finger, would barely fill a few swimming pools. It really is that scarce. And it's scarce because the only way to make it is a cosmic catastrophe so rare that even in a galaxy of hundreds of billions of stars, these collisions happen only now and then. So the next time you catch that glint of gold on a hand, a coin, or a screen, remember what you're really looking at. You're looking at the ash of a stellar explosion. You are holding atoms forged in the death collision of 2 neutron stars, older than the Sun, delivered here by an asteroid, survivors of a journey across space and deep time. You're wearing a piece of an ancient cosmic disaster. And honestly, isn't that so much better than just money?